Okay, in this exercise question, so this is PDE. Here clear mention this is heat equation. Okay, so PDE we have here. Here is the boundary condition. Here is the initial condition. Okay, so there are 6 steps required. First, transform this PDE beginning from u equal to xt. You will have the 2 ODEs. Okay, so the heat equation, the ODE that we will have will be similar with the previous example. Okay, the difference just because here the constant here equal to 1. Okay, the previous example we have constant equal to 4 here. The boundary condition also we have to change using this u equal to xt to have the new boundary condition. So actually if we see the boundary condition here also the same as in the previous case. Okay, we have zero type, zero temperature type, okay, at both ends. So when you transform the boundary condition, it will also having the new boundary condition here will be also x. Okay, but the point will be different. So if you try this, you will get x0 equal to 0, x1 equal to 0 as the new boundary condition. Okay, if you transform this, you will get the ODE x double prime minus lambda x equal to 0. So the ODE for t will be different. You will have 1 over t dt equal to lambda. Okay, please check. I think so. So initial condition we will keep after we sum all solutions. Okay, we have to solve the equation here for the 3 cases of lambda. Okay, so since this case heat equation with this type of boundary condition, actually if you solve for the 3 cases of lambda, you will get the same form as in the previous example, where for lambda 1, lambda 0 and lambda positive, you will get 0 solution. Only the third case, lambda negative, will give the solution. Okay, so you will have for its general solution, you sum all the solution, you will have this form Jn. I'm not sure, I just write n pi x, I think so. Okay, please check the form. You will have Jn, you will have sine function and pi x over L, I think over this number, multiply with exponent negative something here, multiply with t. Okay, so you will have this form of general solution. Okay, so the initial condition here is given. Okay, note see the initial condition in this question. We may expand the series to get that 2 terms. In the previous example, I show you we use the Fourier series method in finding the unknown Jn here. So in this case, if you see here, we have the expanded form, okay, of sine function. So means you can do like this. This condition means t equal to 0, u equal to this. So means if you expand this form, okay, you expand the summation here, n equal to 1, you will have j1 sine pi x multiply with exponent of some n here, maybe n square pi square over, okay, you have to check. Expand further, we will have sine j2 sine 2nx exponent negative t, okay, negative of some number here. Okay, if we see here, we have sine pi x and sine 3 pi x. So I will expand up to j3, n equal to 3. So that I will have sine pi x and sine 3 pi x. Sine 3 pi x, exponent negative something here, t. Okay, so when t equal to 0, means we can substitute u as this one. So on the left now becomes sine pi x plus 5, okay, x here, 5 sine 3 pi x. So on the right, you will have exponent t here 0. So exponent 0 is 1. So all exponent will be eliminated. You will have j1 sine and sine pi x plus j2 sine 2 pi x, and sine 2 pi x is actually equal to 0. Okay, because here does not contain sine 2 pi x. So we have j3 sine 3 pi x. Okay, so by comparing the left hand side with the right hand side, we can say that j1, okay, this sine pi x, we compare with this sine pi x, so we can say j1 equal to 1. j1 equal 1. So if I compare this sine 3x with sine 3x term, I can say that j3 is equal to 5, j2 equal to 0. Okay, so I can say that the solution, I take these 3, okay, j2 equal to 0. So the solution will consist of these two parts. Okay, so un xt equal to jn is equal to 1. So we take the expanded form here. Okay, so sine pi x exponent negative some number here multiply with t, j2 is 0, so plus 5 sine 3 pi x exponent negative some number here. Okay, so this will be the answer for this case.